Welcome to the Math Record. First of all, I want to say I'm sorry for not uploading any math videos for the past few months. My life has been pretty hectic, so I've been in a withdrawal, but now I'm back to cover the ICTM. So I'm going to start off with the ICTM State 2014 Division A Algebra 1, and I'll be going through every single 2014 if I can for Geometry and Algebra 2. Okay, let's get started. Number 1. The equation 4x plus 3 minus 2 is equal to 2x minus 4 plus 12, and 8x plus 6 equals 21 both have the same solutions when solved for x. So they have the same x, so we need to find a. So basically, let's distribute so 4x plus 12 minus 2. Distribute out the 2 ones, so 2x minus 8 plus 12. So we see 12 on both sides, so cancel those out. So negative 2 makes here is a negative 6. The minus 2x here makes this a 2x. So negative 6 divided by the 2 is x equals negative 3. So now you could have ax plus 6 is equal to 21. Sorry that my handwriting is kind of bad right now. Um, and a is equal to, plug in x here. So that's 21 minus 6 is 15. 15 divided by negative 3 is negative 5. And that's your answer for number 1. Okay, pretty simple linear equations. Number 2. Find the greatest odd three-digit number with a hundredths digit equal to twice its ones digit and an even tens digit. Okay, so we have a three-digit number, and the only odd are 1, 3, and 5, and 7 and 9, right? So, and then the hundreds is twice the 1, so that's 2, 6, 10, 14, and 18. So it's not going to be these because that's not a three digit. So it's either a 2, 1, or 6, 3. So it's 10, it's an even tens digit. So since it has to be the greatest, the biggest even is 8. So obviously the bigger one of these two is 683. So that's your answer for number 2. So it's just a simple word question. Number 3. The expression of ax minus 2 squared plus 3x plus 1 squared and 2x minus 5 squared plus 12x squared plus kx parentheses plus c are equivalent for all values of x. So we need to find the product of those variables. So let's have a quadratic term, a linear term, and a constant term, and we'll just call that we'll just call that capital C because it's already a smaller case c, and I don't want to confuse you guys. So for quadratic, let's just work on each one individually. So ax minus 2 squared. So the quadratic coefficient is a, and then linear is negative 2 times 2 is negative 4. Negative 4 times a, so negative 4a. And our constant is negative 2 squared, which is 4, and then 4 times a is 4a. Okay, now 3x plus 1 squared is next. So we have 3 squared, which is 9, so plus 9. And our 3 times 1 is 3, times the 2 is plus 6. And then 1 squared is plus 1. So that is for the first expression. Now for the second expression, I'm going to use the superior to separate them. And then 2 squared is 4. 2 times negative 5 is negative 10, times 2 is negative 20. And negative 5 squared is 25. And then for quadratic, for the other one is plus 12. And this one is 12 times k. And there's no constant except for the one outside the parentheses, which is plus c. So now we have these are equal to each other. So a plus 9 is equal to 4 plus 12. So that is 16 minus the 9. That is 7. So a equals 7. Now we can find k. So we can have a equals 7, and we could plug it in here. So negative 4 times 7 is negative 28, plus the 6 is negative 22, plus the 20 is negative 2. Negative 2 divided by 12 is negative 1/6. And then we have our final value, which is c. So 4a plus 1 is equal to 25 plus c. So we have 28 plus 1 is 29 because a equals 7. So 29 minus 25 is 4. So multiply them together, that's 28 over 6, negative, simplify, negative 14 over 3. And that is your answer for number 3. Number 4. Given that f of x equals 3x plus 14 and g of x equals 2x squared minus 15, find the value for when f of 2x minus 1 is equal to g of x plus 3. So you can substitute x with the f for the x in f of x with 2x minus 1 and the x plus 3 into g of x. So that would be 2x minus 1 times that 3 plus the 14 is equal to 2x plus 3 squared minus 15. So that's 6x minus 3 plus 14 plus 11. 2x squared on this side, so plus 6 times 2 is plus 12. Plus 6 times 2 is plus 9 times 2 is plus 18, minus 15 is plus 3. So now we can simplify this part, so that would be a 6x. Simplify this one, negative 8. Divide by 2, so that's a 1. Divide by 2, that's a 3. Divide by 2, negative 4. So we have a x squared plus a 3x minus a 4 is equal to 0. So we factor that out as x plus 4 and x minus 1. So that's negative 4 and 1. And those are your two answers. Number 5. When x cubed plus kx squared minus 6x minus 17 is divided by x minus 3, the remainder is 10. Find the value of k. So you can plug in 3 in here using the remainder theorem. So x minus 3 means x equals 3. So plug in the 3 into the equation. Plus k times 3 squared minus 6 times 3 minus 17 is equal to 10. So that's 27 plus 9k minus 18 minus 17, that equals 35, 10. So subtracting these two, that's negative 8 equals 10. So 10 plus 8 equals 18, divided by 9 equals 2. So k equals 2. Number 6. In the following number base problem, if 1/6 of 40 base x is 8, okay, so we know that 1/6 of 40 base x is equal to 8. So 40 base x, 0 is going to be our constant. Our linear is 4, so 4 times x. And then we multiply that by 1/6 is equal to our 8. So that tells us that 4x divided by 6 is equal to 8. So that's 48 divided by 4 is 12. Okay, so now we need to find 1/7 of 36x. So we know x is 12, so our constant is 6, and our linear is 3, so 3 times, plus 3 times our 12, and then 1/7 of that. So that's 36 plus 6 is 42, divided by 7, and that is equal to our 6. And number 6 is equal to 6, conveniently. Number 7, a fraction f has the value such that 5/8 is less than f is less than 2/3. The denominator of f is an integer that's 7 more than the numerator of f. Find the largest possible denominator of f. So the denominator of f is 7 more than numerator f. So we could say 5/8 is less than, let's say x is our numerator, so our denominator is x plus 7, is less than 2/3. So to find our x, we just think about these as two inequalities. So it would be this one and this one. So these two inequalities will give us our bounds. So the only one that we actually only care about is actually this one. And the reason is because if we're trying to find the largest possible denominator, that means we have to use the upper bound, right? So x is bounded by something upper right here, but we need to find that as an integer. So using the upper bound, we're able to find the largest possible denominator. So using this, we have 3x cross multiplying is less than 2x plus 14. So that's x is less than 14. That means x is equal to 13 because it can't be 14. So next height is 13. So find the largest possible denominator. Denominator is x plus 7. So x equals 13. So 13 plus 7 is 20. So your answer for number 7 is 20. Okay, we finished the first 7. Now let's move on to the next one. 8. Let D represent the absolute value of the difference of the squares of two consecutive positive odd integers. So if the first odd is x, that means the second odd is x plus 2. So we need to find the difference of the squares of the two consecutive. So that one's x plus 2 squared, right? Sorry, it's not x plus 1 because that's going to make it, if this is even, then this is going to become an odd if this is 1. And if this is the odd, this becomes an even. So if we want two consecutive odds, it has to be an x and then two more after that, right? It's 1, 2, 3, right? If you think about the number line, you have to every single two numbers is going to become the odd. So x plus 2 squared minus x squared is equal to your difference, which is d. Absolute value just means it has to be positive, and it's definitely going to be positive because x plus 2 is bigger than x. And then let m represent the arithmetic mean. So x plus 2 plus x divided by 2 is equal to m. If d equals km, find the value of k. Okay, so let's simplify this first. So k squared minus this k squared cancel each other out. 2 times x times another 2 is 4x. And then 2 squared is plus 4. That's our d. And then x plus x is 2x divided by 2 is just x. And 2 divided by 2 is plus 1. It's equal to m. So how do you so the constant is in front of the m. So how do you relate from m to d? Well, to get from m to d, you gotta multiply to 4. So that's your answer for k. I mean for number 8. K is 4. Okay. Got to make a layer, so I had to backspace. Okay. Number 9. Find the largest value of x for which 8x plus 4 squared is equal to 12 times 2x plus 1 plus 10. Okay. So we could have, since I noticed that 8 and 4 are multiple to each other, we could just split them up. So it'll be 4 times, in our parentheses, 2x plus 1, and that is still inside squared, equals 12, 2x plus 1 plus 10. Now you can move the 4 outside the parentheses. So 4, when you move out the parentheses, it also takes one of the exponents to 2. So 4 squared is 16. 2x plus 1 squared is equal to 12. 2x plus 1 plus 10. And now you notice something. 2x plus 1, 2x plus 1. And there's our exponent, and this one's linear. So it's got to become a quadratic. So we could replace 2x plus 1 with a. And then we could find a, and then we go back to x. So then we have 16a squared. Move everything to one side. So 12a minus 10 equals 0. Simplify 8x squared. 8a squared minus 6a minus 5 equals 0. So the only way to make 5 is 1 and 5. And 8 is way too big to make a 6. So the only way would be a 4 and a 2. So now we just need to know where it goes. So 4 and 5, that's a 20. That's too big. So it has to be a 2 and a 4 this way. So a here and a here. So we need a negative 1. So 2 times 5 is 10. That's 4, 6. Okay, that's possible. So we put a negative here and a positive here because we want the bigger negative. And that's usually how I think about it. It's an intuitive way to think about how to factor these numbers out rather than using like the quadratic formula or whatnot. And now we have a is equal to negative 1/2 and a is equal to 5 over 4. So now we have a's, but we need to look for x, so we need to plug it back here. So if a equals negative 1/2, the minus the 1 would be another negative divided by 2 is negative. So since we're trying to look for the largest value of x, it's not going to be this one. So we have 5/4. So 5/4 minus 1 is 1/4. 1/4 divided by 2 is 1/8. That's our x. So 9 is equal to 1/8. Number 10. Express the repeating decimal 2.014 repeating, the 4 is repeating, as an improper fraction. So to do this, we could represent our repeating decimal as a variable, and then we could scale up to a 10x. So then we can move one decimal place over, so that's a 20.14, and then the 4 is repeating, right? So it goes on forever. So what we could do is we subtract these two, so that's 9x. 20 minus the 2 is 18. And 14 for repeating, and 0.01 for repeating. The 4 repeating cancel each other out. So the 14 minus the 0.1 is just a 13. So x equals 18.13 divided by 9. And to simplify this, to get rid of the decimal, we just need to multiply it by 100. So that's 1813 over 900. And that should be your answer, 1,813 divided by 900. You could check that 1,813 is prime relative to 900. Not that 1813 is prime, it's just you cannot factor it down anymore. Number 11. An odd and an even number are picked at random for the first 10 positive integers, so it will be from 1 to 10, right? 1, 2, 3, 4, 5, 6, etc. to 10. Find the probability that their sum is 11. So the only way to make to 11 using these numbers is 1, 10, 2, 9, 3, 8, 4, 5, 4, 7, and 5, 6. Okay, so these are the only ways to make to 11. So from 1 to 10, 1 plus 10, 2 plus 9, 3 plus 8, 4 plus 7, and 5 plus 6. Or you could do the reverse, which is 10 plus 1, 9 plus 2, 8 plus 3, 7 plus 4, and 6 plus 5. So that is a total of 10 combinations, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? It's just each pair has two possibilities. Now that's the amount of outcomes that work. Now what's the total amount? Because we need to get the probability. So it says they need to pick an odd and an even. So what's the probability that you choose an odd first and then an even? So an odd is 1, 3, 5, 1, 3, 5, 7, or 9. So there's 5 of them. And then to choose an even, there's another 5, which is 2, 4, 6, 8. Okay, and 10, right? So that's 5. So that's odd first and then even. So what happens if it's even first? So even has 5 also, and odd also has 5, so it's the same thing. So it's 10 over 5 times 5 is 25, plus the other 25 is 50. So we have 10 over 50, which simplifies to 1/5. And that's your answer for number 11. That's usually how you could think about how to solve probabilities. Just split them into parts and then just work on it by itself. Number 12. The points 6, 3, negative 1, 2, and 9k are collinear, and k is equal to m over n. Find the value of square root of m squared plus n squared. Okay, so first we need to find the slope. So 2 minus 3 over negative 1 minus 6. So that's negative 1 over negative 7. So our slope is 1/7, right, using the first 2 points. Now let's use the second and third point. So k minus 2 all over 9 minus negative 1, which is 10. So that's 10 equals 7k minus 14. So 24 divided by 7 is equal to our k. So our m is 24 and our n is 7. So 24 squared plus 7 squared, square root that. If it's, you could do it with a calculator if you want or do it by hand, but it's actually going to be 25. And the reason I know this is because it's a Pythagorean triple, which is 7, 24, 25. So we have a 7, 24, so the next one's 25. So I recommend you just learning some of the Pythagorean triples because they're really important. Like the 3, 4, 5, the 5, 12, 13, the 7, 24, 25, the 8, 15, 17, the 9, 40, 41, and I think the 11, 60, 61. So you can remember like the first 5 or the first 10, and that should be enough. Okay. Kelly rides her bike 3 miles each day to school. The first mile is uphill, and she rides at a constant rate of 4 miles per hour. So the first one's uphill, and it's 1 mile, and she goes at 4 miles per hour. And the second is downhill, and she coasts at a constant rate. That's an integer. Okay, so let's 1 mile. So it's an integer, so let's use I so we don't forget. And it's faster than the uphill rate, so I is bigger than 4. And it's less than 60, so it's less than 60. For the final mile, she rides at a constant rate of 6 miles per hour. So for 1 mile, 6 miles per hour, mph. So her average speed is an integer. So find the speed when she coasts down the hill. So our speed downhill is an integer, and our average speed is an integer. So our average speed is calculated by total distance divided by total time. So total distance is 1 mile, 1 mile, 1 mile. So that's 3 miles. And our time, so the time to go up is 1/4, because 1 divided by 4. And the time to go down is 1 divided by I. And the time to go constant is 1 divided by 6. And that equals to our average. Let's call capital A. And this is an integer. So Let's simplify this all down. So 4 and 6, the least common multiple is 12. So that's going to be a 3i on here, a 12 here, and a 2i on here. So that's 3i plus 2i is 5i, and then plus that 12. So on the bottom is 12i, so 12i times 3 is 36i is equal to a. If you don't know what to hear, just like take your time to like work on it. It's basically just simplifying, and I'm condensing them down instead of having two fractions, like a fraction divided by a fraction. And now we have a 36i divided by 5i plus 12 equals a, and I has to be integer. So how do we find I? Well, what we could do is we already know the bounds for I, so we could have the bounds for a. Okay, so let's put, because a has to be an integer, so we could bound a, and then we could just find I. So plug in 4 for I, so that's 36 times 4 divided by 5 times 4 plus 12, and that is 9 over 2, which is 4.5 for a, lower bound. And upper bound, we put 60 in here. So 36 times 60 divided by 5 times 60 plus 12. And that comes out as a rounded decimal, which we could say is 6.92, right? Since a has to be an integer, right, that means it has to be either a 5 or a 6, because that's between 4.5 and 6.92. So we could rewrite this all as, we don't need the rest of this anymore, actually. And I also need room, mostly because I need room. So we have 36i over 5i plus 12 is equal to 5, or 36i divided by 5i plus 12 is equal to 6. So let's delete this, and let's work on this. So we could just cross multiply, so there's 36i is equal to 25i plus 60. 36i equals 30i plus 72. Right? So 36 minus 25 is 11. 60 divided by 11 is not an integer, so I has to be an integer. So if it's not an integer, it's not right. And 36 minus 30 is 6i equals 72. So 72 is divisible by 6 for an integer, and that makes 12. So that means her speed downhill is 12, and that's her answer for number 13. Number 14. There are 20 married couples in a group. Each couple is one man and one woman. Find the number of ways two people can be selected, considering of a woman and a man who is not her husband. Okay, so let's just separate them into women and men. Sorry, I wrote I because I was thinking integer. Okay, so we could have x, 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 etc., right? And then you just I'll just use a bunch of dots to represent the rest. I'm not gonna write every single 20 because it's unnecessary. So each one opposite of them, that's their husband. Okay, makes sense? So what we could say is if we choose the first woman, right? How many possibilities does this first woman have? Well, she can't choose her husband, right? And there's 20 of each of them. That means if this one doesn't work, that means the other 19 works. So for this woman, the first woman, we have 19. Okay, now the second one. So the second woman cannot choose her husband, but she could choose the first male, and they could choose the third, and then the fourth, and then the fifth, etc. Right? So there's 20 of them, remember, and it can't choose her husband, so that's also 19. Okay, so now let's go to the third. It can't choose her husband, but it could choose the first two and then everything else after that. So it's just minus that one from the 20, so that's also 19. So as you see, there's 20 women and they all have 19. So it's 20 times 19 because that's a total amount, and that's 380. So your answer for the amount of ways is 380. And you could just think about this as a diagram and it'll be easier than actually like trying to use some combinations or permutations. 15. Solve for t if y equals 4x times a of t plus 1. And you don't have to like read the rest of these usually because they're just telling you it cannot be undefined. So y, let's just minus 1 because it's a constant. So 4a over xt So we need to solve for t. So let's just switch the denominator and the one that's equal to. So 4a over y minus 1 equals xt. So that means our t is 4a divided by x times y minus 1. That's equals to t. And you could just write it like this. You could distribute out the x to make x y minus x, but it's still the same thing. And that's 15. It should be that simple. Find the values of x for which x plus 5 minus 2 squared over x plus 5 is equal to 15. There's several ways you could do this. You could like move them each to separate sides and then square it, and then you could solve it like that. But the way I like to do it is that I like to use substitution. So we could say x plus 5 is equal to a squared. So we have a squared minus, so we have x plus 5, that's just square root x plus 5, that's just x plus 5 to the power 1 half. So that's just 1 half of a squared, which is just a. So minus 2a, and then minus the 15 to the other side, so 0. So that's x minus 5, because that's a negative, so the negative have to be bigger. So a plus 3 is equal to 0. So a equals 5 and a equals negative 3. And the reason I like this method is because now we can tell which one is extraneous, because this is extraneous. Because remember, a, um, because x plus 5 equals a squared, and our a is equal to square root of x plus 5. So that basically tells us that a has to be positive. It cannot be a negative. So a has to be equal to 5. So that's equal to, which a is equal to square root of x plus 5. So now we find what x is. So that's 25 equals x plus 5. So x equals 20. And that's our answer for number 16. Number 17. Find the smallest possible integer greater than 1,000 that leaves the same integral remainder when divided by 30, 36, and 50. To solve this, you gotta think about this as multiples. So let's just actually solve this first. So divide by 3, that's a 10, which is a 2 and a 5. So 3, 2, and 5. 36, that's a 4 and 9. A 4 and a 9, they're both perfect squares of 2 and 3 respectively. So we could just rewrite it as 2 squared times 3 squared. And 5 divided by 2, that's 25. So that's 2 and a 5 squared. So we have a 2 squared, a 3 squared, and a 5 squared, right, as our overall least common multiple. So so that's 4 times 25, which is 100, times 9, which is 900. So any single multiple of 900 divided by these number is gonna have a integer solution, right? So if it leaves the same integer remainder, you could just have a multiple plus a remainder, and anything divided by whatever numbers 36, 36, 50, 30, 36, 50, it's always just gotta be that remainder plus some kind of integer. So it's gonna be kind of like a factor with that same remainder. So it will be 900, every single 900 multiple. So it has to be greater than 1,000, right? So 900 is obviously less than it. So the next multiple is 1,800. And then for it to leave a positive integral remainder, because if you divide this by 1,800 divided by 30, 36, or 50, it's going to be an integer. So for it to have a remainder, and for it to be the smallest, you could just add the smallest. So that's add a 1. So that's your answer, 1801. That's just the way you could think about it. Just think about LCM, think about the multiples, and then just add 1 to it to get the smallest. Number 18. The number 5,760 can be expressed as 4 to the power of a, 5 to the power of b, and 6 to the power of c. And then find the value of a plus b plus c. Okay, so use your calculator. You could factor out 5,760, or you could do it by hand. I prefer using a calculator for these because it's kind of tedious and you can save a bunch of time. So 27 times 3 to the power of 2 times 5. Okay, so 4 is equal to 2 to the power of 2, so that's 2a. 5 times 5 to the power of b. And 6 is 2 times 3, so it's 2 to the power of c times 3 to the power of c. So adding the 2's together, so 2a plus c, those are 2, so it's equal to our 7. Our b is the 5, which is equal to 1, and our c is equal to 3, which is equal to 2. So now we just need to find a. So if c equals 2, that means a is 7 minus 2, which is 5. 5 divided by 2 is a equals 5 over 2. Now we just need to add them together. So 1 plus 2 is 3. 3 times 2 is 6 over 2. That equals to 3. 6 over 2 plus 5 over 2 is 11 over 2. And that's your answer for number 18. Number 19. Find the value of x so that 1 to the power of x equals 2 to the power of x plus 1 equals 0 to the power of x plus 2 plus 1. Okay, so 1 to the power of x is always just going to equal 1. So for a 2 to the power of x plus 1 to equal a 1, x has to be equal to negative 1. Because 2 to the power of 0 is always going to be 1. Anything to like power 0 is like 1, right? So x equals negative 1. And that's the only one that works for 2 to the power of x plus 1. Now let's see if it worked for the last one. So negative 1 plus 2 is 1. 0 to the power of 1 is 0. 0 plus 1 is 1. So the only one that makes sense is negative 1, and that's your answer. 20. If x plus y is equal to 7 and 1 over x plus 1 over y equals 3/8, find the value of x squared plus x times y plus y squared. Okay, so we know x plus y equals 7. So simplifying this is just x, 1 over x plus 1 over y is the same thing as you use the least common multiple. This is just going to be y over xy plus x over xy, right? So multiply y here, multiply x here. So that will simplify as x plus y over xy is equal to 3/8. We already know what x plus y is. That's 7. So 7 over xy is equal to 3/8. So that tells us that xy, just switch the numerator and denominator, so that's 8, 3, and then multiply the 7 to get your xy. So that's 56 over 3. So that's your xy. So the reason I found this is because if you think about what x squared and y squared is, that's just x plus y squared. So we just have x plus y squared. Now think about it. So this factors out as x squared plus y squared plus 2xy, right? This is just xy, not 2xy. So to get rid of that, we just make a minus xy. So we just need to find this because that's what's equivalent to our value. So we know what x plus y is. That's 7. So 7 squared is 49. Oh, sorry, 49. And minus xy, we know what xy is, so it's 56 over 3. And then you can just use your calculator because I don't want to do this by hand. 49 minus 56 over 3, and we get a 91 over 3. And that's your answer for 20. And that basically completes everything. So generally for Algebra 1, as I've been saying for a bunch of these videos, you gotta think like kind of outside the box. So don't just like solve for x and then solve for y and then like put them all together to get the answer. You might want to think about how they work together in tandem. And there's some recurring ones with like factors and divisors and quadratics and radicals, some probability and random slope questions, and that's basically it. Sometimes they have base change questions, so you might want to learn those. But generally, everything should be pretty simple for Algebra 1. Well, thanks for watching, and I'll see you at the next math record.